Autonomous machines. You see, today we bring one, XS125. He is one of the autonomous machines, a member of the cluster. Yeah. In China, we have so many job sites. We have to test, and we also sell the machine to the customers. We started this project in 2016. Why we do these autonomous machines is because we do an investigation for looking for the next generation, where is the direction the road construction machine it is. And we found 4 reasons. The first is cost. People always want to reduce cost. You know, the job side means time means money, and job side means money. And the second, efficiency. You know, efficiency means the time. If you spend 1 year to finish a job site, it costs, for example, 1 million. But if you spend half a year, that means you can save a lot of money. And the second is the cost. First is cost. Second is efficiency, and also is quality. Quality for the especially the road construction is very important, because if you drive a car with your family, in the car you can feel in the road. The evenness means the quality, and also if quality is not so good, the lifetime of the road will go down. And the last is very important is the safety, because we can see the road machinery, they work. So many people around the machine, they have to solve some problem of the material, and also the machine have a driver operator there. So if no man drive in the cabin, we can reduce the risk of the job site. This is the 4 reasons why we do autonomous machines in the 2016.
You mentioned the word cluster. Explain to me what the cluster is.
Oh, the cluster. The story can start from 2016. The first generation we do autonomous machines only 1 machines, because we do soil works only 1 machine in the job site, or the dam, or the airport. 1 system control 1 machines. We give the parameters, then the machine can autonomous work in the job site and follow the parameters, the setting parameters. Then after finish the work, the machine will send a message to the operator, I'm okay, I'm finished. This is the first generation. And the second generation is cluster. It means, so you know, for road machines, always paving road. A paver in the front, and some tandem roller or tire roller will follow the pavers, because where the area paver do is the roller have to compact. Then we call it cluster. The cluster have master and the sliver. Master is the paver. He knows the area where the roller have to compact, and the roller will follow the paver. A paver know everything about the job site. So he sends the message, sends the order to the sliver, how to pave, how to compact, how many times you have to pack, and like a conductor. So this is cluster.
You've mentioned compaction. Compaction is a very complex business. In traditional compaction, you're relying upon an operator to look at it and to feel it and to get an idea of whether they've achieved a level of compaction. You're doing that autonomously. How does that work?
A good question. Let's go to the 3rd generation. This year we release the 3rd generation of the cluster. You know, the quality must be achieved by the system. Normally, the customer use traditional equipment. the quality is the operator's function. You know, the operator must take responsible for the quality. But if no man drive, the machine must know the material's condition. So the third generation of autonomous system, we add so many sensors. The sensors is not for the environment to protect people, but also very important thing is to feeling the material situation and know now the road, the material need how many times compact, and then send the order to the roller. The roller know the material situation. This is why we release the third generation for feeding the material.
You've done 3 generations in a very short space of time. Does that mean there's a 4th generation just coming down the line?
We start this autonomous project at the year 2016, and the first generation we release is 2019. So we store so many technologies before we release the first generation, and we release the technology step by step, because you know autonomous machine must be safety. So we test every details. We test every step of the autonomous machines to make sure the machine is safety, make sure the job site is safety enough.
There is always that question about autonomous machines that mean people are going to lose their jobs. I know that the situation is different in China, but here in Europe, you still require a person in the cab of the machine.
Yes. In China, we don't have the limitation of the road construction machines for autonomous. So this year, we have 17 job sites already use autonomous machines. And in Europe, you know, the CE certification is limited. The driver machine cannot work without driver in the cabin. So, if this what the autonomous machine means, we are working on this to do some standard to push the technology. Maybe we can start with a safety direction for autonomous rollers, and then for pavers, and then to the cluster. Then if CE, you know, it's a government, then he allowed this technology to the job site. We can push this kind of technology use in customer and the job site.
My final question, the autonomous machines that you have here have cabs on. We've just said that you will have people in the cabs. How easy is it to switch from autonomous to usual regular operator?
A switch.
A switch.
A switch is very easy. And for example, if you are operator, go to a job site, then the area you want to compact, you can add the position parameters, and then the machine can follow your order. And if you want to drive yourself, one key, switch to normal mode, then you can drive. So that's why we use a cabin in the autonomous machines. The people can choose.
I realise that you're the expert on the compaction or the road machinery side of things, but the fact that XCMG now has autonomous capability, do you see that being applied into maybe excavators and wheel loaders and that kind of thing?
For the other machines, for example, excavator, we now we do a assistant system, and then the next step may be assistant second generation, and then step by step. Then I think in the end we can achieve autonomous. But the first step is assistant, to help the driver to dig, We already have a 3D system for the excavator. So, for example, if a job site have a modeling, you know the modeling of the job site, the construction job site, then the design company will send the modeling data and transfer to the machine's language, and then the machine can know where I have to stop, where I have to a little bit dig deep, or get back the digger. This will help the operator for the first step, I think. Then we maybe give the machine more ability to help the operator step by step. And we also have so many other machines we use assist system.